Hello everyone, I am Vivanchala. Welcome to my YouTube channel, Space Engine. This is a series of short videos in which I will explain some concepts about the universe, as such, theory of general relativity, dark matter, and particle physics. I will upload every day, so stay tuned. I hope you enjoy.
Today's topic is unity. Matter is made up of atoms. This was a speculation, as we have heard, by Democritus 2500 years ago, but he didn't have any data or observations or experiments to support this hypothesis. In the early 20th century, elegant experiments by Rutherford and others showed that there were tiny indivisible particles that we call atoms. The structure of atoms was only unveiled by high-energy physics experiments through the middle part of the 20th century. In the 19th century, it was thought that atoms might be billiard balls or BBs, tiny indivisible particles hard-edged. But experiments by Rutherford and others in the 20th century show that this is not the case. Rutherford's elegant experiments shows that atoms are almost empty space. When he fired charged particles through the thin gold foil, much to his surprise, most of those charged particles passed straight through as if the atoms weren't there. We know from his experiments that atoms are 99.99999% empty space. Occasionally, a charged particle would violently recoil from the nucleus of an atom, and from that violent recoil and the same beautiful set of experiments, Rutherford concluded that there is a tiny atomic nucleus having 99.9% of the mass of every atom and a diffuse cloud of negatively charged electrons, both occupying most of the volume. Each unique atomic number corresponds to an element, and that is the number of protons in the nucleus. 1 for hydrogen, 2 for helium, 6 for carbon, and so on. Atomic mass, however, involves the entire mass of the nucleus, which is a combination of neutrons and protons. Neutrons and protons have about the same mass, but neutrons have no electrical charge. The uniqueness of an element comes from an equal number of protons in the nucleus and electrons surrounding it. Neutrons do not play into the electrical force because they do not have an electrical charge. We define an isotope of an element as a version of that element with a different number of neutrons. The varying number of neutrons does not affect the chemical behavior, and so it's the same element, but it's an isotope because it has a different mass. Some isotopes with large numbers of neutrons relative to protons can be radioactive and decay. Molecules are one or more atoms held together by the electrical force. There are many types of molecules. Some experiments have shown that neutrons and protons have substructures. Meanwhile, similar experiments on electrons could not detect substructures. Electrons appear to be truly fundamental particles. These experiments showed that protons and neutrons have subconstituents called quarks. These quarks are fractionally charged, which is a very unusual situation for subatomic particles, never seen before. The size of these atomic particles is incredibly small. The atomic nucleus is a few parts in 10,000 compared to the size of an atom. The quarks are on a scale hundreds of millions of times smaller than the size of an atom itself. It took enormous energies to liberate evidence of these quarks, and the quarks themselves cannot exist as free particles, but hints of them were seen. But they also provide a wide array of subatomic particles, some of which only lasted a very short period of time, and a struggle to produce a pattern of all these subatomic particles. The particles exist in families with different mass ranges, and as yet there is no fundamental explanations as to why particles are arranged this way.
Thanks for watching. Please share your thoughts and ideas in the comment section below. Bye.